Oh, it's going. Okay, on number 3, Emma, let's read since you're already talking anyways.
I would love to read.
Oh, yeah.
The length of one base is a trapezoid is 3 times the length of the other base. If the length of the mid-segment is 26 feet, fin the length of each base. I think that means find, but you know, it's just that.
Did it say fin on there?
It does say
You know, context clues, you'll be fine. All right, so on this one, what shape do I have?
a trapezoid.
So let's make our trapezoid. And do we know if it's isosceles or just a normal?
Can't draw a trapezoid.
We don't know anything about the isosceles, so make one extended. And they gave us the mid segments. That means this point is a midpoint, and that is a midpoint on its own. And when I connect, it's going to give us the average between the top and the bottom. What information do I know so far?
The mid-segment.
The mid is 26. The top is what of the bottom? The top is the x, and the bottom must be 3x. And to find the average, you always start with the middle. 26 is equal to the average between the top and the bottom. And when I do, I think I'm going to go ahead and combine like terms and multiply by 2 at the same time. So 52 is equal to 4x. And how many would be my x? 13. And it says find the length of each base. So not only do I know it's 13, I need the other one. 30, 9, and I should put in the units. Go with that one? Okay. Now let's go to, yes.
Should you put 3x for the second answer?
Did I write x on there? You know, every question you're asked, you're looking for x in my opinion, but that's okay. All right, on number 4, we're gonna need some highlighters. And I'm gonna use that theorem or the property that we talked about from, I think, the first or second lesson. And let's first analyze so we know what I'm talking about. So let's put in the givens that we know. HN is bisecting MT, so it's going to cut. This is going to cut the MT in half only. So here is MT. So if it is bisecting, we have a midpoint. And then let's go ahead and notate angle DHM. DHM, this angle is congruent to DNT. Y'all remember the saying for segment bisector? It was stupid, big, mama cat. Let's do a reminder. Stupid, big, and if you don't like the word stupid, you can use silly. Mama cat. And all that it meant was, when segment bisector is given, we state the midpoint, then congruency. So let's follow that order on the first 3.
Wouldn't technically DHT and DNM be like equal to?
H,
Because of yeah.
T,
DHT
and
NM.
MNH.
MNH. What? Oh, wait, yeah.
That's if I tell you it is a rhombus or parallelogram to begin with, but I'm asking you to prove that it is a parallelogram. Okay? All right.
MD and HDT.
Yes, you can. HDT, right? That'll be vertical angles that we're going to use in a little bit. Okay, let's go ahead and list them. HN bisects MT, and that's by the what? Given. And the second one, we have to list the midpoint. So who is a midpoint right now? D is a midpoint of who? MT. And that's by definition of segment bisector. And then a CAT stands for congruency. So what 2 segments are congruent to?
MD and DT.
MD is congruent to DT. And to be perfect, I should put a segment symbol above it. And that's by definition a midpoint. So now that we're done analyzing the first given, let's go on to the second given. So angle DHM is congruent to angle DNT. And that's by the given, of course. So something that I want to mention in regards to those 2 angles. If I go ahead and make 2 lines that would make a bound out of this, and it's transversal. What were those 2 angles called back in unit 4-ish? Alternate interior. So if alternate interior angles are congruent, what do I know about those two sides? They are parallel. So let's list that as our second one. MH is parallel to NT. And that is if alternate interior angles are congruent, then two lines are parallel. And earlier, before the proof, or around the beginning of the proof, someone said something about vertical angles. Given that we're using these two angles, is it smart to use a vertical angle on the top and the bottom, or left and the right? Left and the right, because the left and the right is going to pertain to that specific triangle and more information. So these two are congruent too. So let's go to angle, and how you name it doesn't matter, just be consistent. Let's say I go in the order of MDH. Is congruent to. How should we order on the other side?
TDN.
TDN, and that's by vertical angles are congruent to. And now let's see if we have enough information within just one triangle. Angle, angle, side. Is that true? So let's put on here number 7 is angle, angle, side. And why not just name it the same way, in the same order as the angle above? Triangle MDH is congruent to triangle TDN. Ooh, that's a T. DN. And the theorem that I want to use, and I have mentioned this previously, go to number 9 and write out something. If one pair of opposite sides are congruent and parallel is what I want to use, then we know the quad is a parallelogram. Okay, speaking of this symbol, can I use this symbol for any other shape? No, just this one. Oh no, I can't even zoom out. Oh well. So then let's see if I have all the conditions met. We have the parallel met right here. And I wanted to also say that same thing is congruent to the other part, which is going to satisfy the congruent piece. So why not go ahead and notate? These two are congruent to these two. What is the reasoning after the two triangles are congruent to typically? CPC, TC. Corresponding parts of congruent triangles are congruent to. Then I know H, M, and T is a parallelogram. Very much. Let's go to number 9. Was number 9 the weird one?
Yeah.
Someone said? Okay.
She shaped a little funny.
That's okay. So on number 9, let's kind of see what parts are given. First of all, what shape is this? Hexagon. Okay, so that means our n is equal to 6. And it says to find the measure of angle ABC. So ABC is this angle right here, is what we're looking for. So I need to first figure out what is my total angle measurement. So we know the sum of all interior angles were n minus 2 times 180. And when I do n minus 2, that's going to give us 4 times 180. How many is 4 times 180?
72, 0.
72, 0. 720.
That one.
And notice it's got swing marks. That's got one going around and the two sets, right? So that means I can repeat 95 here, 95 here, and here. And I don't have a calculator on me. So someone type in 95 times 4. 380. So I have 720 minus 380. And that's going to give us how many? 340. And I want to take that and divide it by 2. And that's going to give us 170.